Welcome back, students. We will be just continuing with the correlation part and the term called as a correlation coefficient. The correlation coefficient, it is a degree of relationship, or it is a measure of degree of relationship. So in correlation we are able to measure the degree of relationship, and this degree of relationship between the variables lies between 1 and -1, and the signs refer to the direction. Whether it is positively directed, then it will be a positive value, and if it is negatively related, then it will be a negative value. And based upon this covariance, that is a measure of degree to which the large scores on X goes with the large scores on the Y, and the small scores goes with the small scores of the Y. And these variables, so this is an example for the scatter diagram, and it is a simple method of studying the relationship between the two variables. Here it is a X variable and here it is a Y variable, and the correlation is represented by the letter R. Okay, so in the scatter diagram the values of one variable are represented along the X-axis, and the another variable, it is represented in the y-axis, and each pair of the values is plotted on the graph by the means of xy plane. So the values are plotted on this xy plane, and the diagram of the dots so obtained is known as a scatter diagram. And this type of diagram, which is obtained after plotting the values of x and the y in the xy plane, you will get a diagram like this, and this is called as a scatter diagram. And the placement of dots on the graph reveals the nature of relationship between the variables. And if the points are scattered much away from the point, away from a straight line, we say that it is not much, the variables are not much correlated. And if the values, or if the dots are along a single line, then we say that it is correlated, or the relationship, it is good, there is a good correlation. And if the line, it is a straight line towards the upside, then we say that the x and the y variables are positively correlated. And if it is downwards, then we call it as we say that it is negatively correlated. So if the points show a tendency to cluster around a well-defined line, we say that the relationship, it is a linear type of relationship. Upwards, this step, it is a linear relationship. And the scatter diagram can also give the idea whether the relationship, it is direct or inverse. As you can see here, it is upwards, and here it is downward. So this diagram, scatter diagram, represent a positive correlation, and here it is a negative correlation. Okay, so these are the views that we can reveal from a scatter diagram. So that is all about the graphical method. So there are the graphical method and the scatter diagram method. These are the two type of representation of correlation. And there is an algebraic method, that is a first, it is a Pearson correlation coefficient. That is the first type of correlation type, and there are the many kinds of correlation coefficient, but the most commonly used of measure of correlation, it is a Pearson correlation coefficient. It is represented by the letter R, and the value ranges from +1 to -1, and the sign indicates the direction. It is a numerical value increase, indicates the strength. Okay, so if it is having a perfect correlation, if the values, we get a values between -1 or +1, and if we get a value of 0, then we say that the variables are not correlated, and the correlation of 0 indicate the value which is not linearly related, and it is possible that the related is curvy linear fashion. Curvy linear is somewhat a curve like. Okay, so the Pearson correlation coefficient. So in biological data, if you want to find the relationship between the variables in a biological data, we use a method called as a Pearson method, and by using this formula, R is equal to sigma dx dy divided by the root of sigma dx square into dy square. So this is an equation by which we are able to calculate the Pearson correlation coefficient, and it is the most widely used method. You know what is D? It is a deviation. D is a deviation, and x and the y are the variables. Sigma, it is a sum. So we have discussed in the class what is D, that is a deviation. How to calculate the D? It is x minus x bar. X bar, it is a mean of x, arithmetic mean of x. So how much the x value it is deviated from the mean. Okay, so let's see an example. Here in this example, the length of the fish and the weight of the fish is given. So these are the values, two values, and the question is how to calculate the correlation coefficient. The first we have to find the arithmetic mean, isn't it? In order to find the deviation, you have to find the mean. You have to find the x bar. Okay, so here there are the one more variable is the y variable. So you have to find the mean, arithmetic mean of y series also. So you have to find the x bar and the y bar. And how to find the mean? It is the sigma x by n. That is a mean for x. Similarly, find the mean for y also. That is the sigma y by n. So you already studied it. And square the deviation. So in order to find the solution, you can just tabulate your data. You can just enter the x value, you can enter the y value, then you can find the dx, that is x minus x bar, that is a deviation for x and deviation for the y variable, then square it. Then you have to find the dx into dy. Then you have to find the square root. You can just substitute the values in the equation, and you will be getting an answer. Here you are getting a value close to 1, and the value is a positive value, and so we say that x and y variables are positively correlated. That is the interpretation of the result. Now we will just pass on to the next type, that is a Spearman rank correlation coefficient. Actually this coefficient is calculated by an equation 1 minus 6 sigma d square by n into n square minus 1. And the Spearman rank correlation coefficient, it is represented by the letter rho, RHO. And this rho, it is a rank differences between the x and the y variable. The d, it is a deviation. So let's see an example. This is an example showing the length and the length of the plant and the number of the fruit. And here you will be first arranging the values in the ascending or the descending order. Then you will be giving the just ranking to the each variable values and substituting the values inside the equation. Okay, this correlation I think we have discussed in our theory classes, so you just go through that. Then there are certain limitations for this correlation. These are the limitations, that is this correlation does not completely tell us about anything about the data. That is, the means and the standard deviations continue to be the more important. Okay, so in order to calculate this correlation, we are just purely dependent upon the mean values, isn't it? So that's a limitation. Then the data may be described by the curve more complicated than a straight line, and thus it will not show up in the calculation of the R value. Just because the two sets of the data are correlated, that is only the X and the Y values, then it doesn't mean that the one is a cause of the other. There may be the other more variables which is interacting with the X variable and the Y variable, so that is not taken into consideration. So that is also another limitation. So in any real life situation, it is not only the two variables that is dependent. In the actual real life incidents, there are the many variables that are interdependent. Okay, so we can't say that the one as one increases, the other decreases due to the effect of the other. So we can't say truly X and Y as a dependent or not dependent or etc. Okay, so there are the certain applications in the real life situation in the posterior correlation. So as you all know that as the number of the trees are cut down increases, the probability of the erosion increases, isn't it? And the cause of the erosion is not only the cutting down of trees, isn't it? Okay, so there are the many other, there may be the climatic factors, etc. So those are the other reasons which we are just neglecting. Okay, so this is one of the real life application of positive correlation. Then as the second example is, as a student study time increases, so does his test average. Okay, so if we increase the time of the student to study, it doesn't mean that the student will be scoring more marks. Okay, then as a child grows, so does his clothing size. So that is a positive correlation. Then her salary increased, so did her spending. So these are all dependent variable. Then these are the negative correlation, that is a student's absence increases, the grade decreases. The weather cooling increases, the air conditioning cost decreases, isn't it? Then the train speed increases, the length of the final point decreases. Then kitchen age increases, the amount of the egg producing decreases. So these are the some of the negative correlation that we come across in the daily life. Then this is another example showing the correlation. As the temperature increases, the sales income increases. The sales of the ice cream increases, the sales of AC increases, isn't it? So as the temperature increases, there is an increase of these commodities and in turn increases the sales. Okay, so it's another positive correlation. So this correlation, if you just plot here in the graph, this diagram is called as a scatter plot. Here the values are plotted in as a dots, and this is a scatter plot. And you can see it is a slight positive correlation as it forms a linear increase from the left hand side to the right hand side. Then about the exercise, amount of exercise increases, the percentage of fat in the body decreases, isn't it? As the one increases, the other decreases. So by this we end the topic called as a correlation. So you have to study what is correlation. Then you have to study the type of correlation, then the graphical method, scatter plot method. Then you have to study about the few examples of correlation, the positive and negative examples you have to study. Then you have to study about the correlation coefficient. There are the two methods, algebraic methods, by which we are able to measure the correlation. Thank you.